In the heart of modern hydropower engineering lies a marvel of precision and strength, the hydraulic turbine. These incredible machines convert the raw energy of flowing water into mechanical power, which is then transformed into electricity to illuminate cities, drive industries, and fuel the modern world. But the journey of a hydraulic turbine from concept to operation is a story of meticulous design, raw materials, industrial might, and human expertise. Every great turbine begins in the minds of engineers. The process starts with careful planning and detailed computer simulations. Engineers sit before multiple monitors, studying three-dimensional models of turbines as they rotate in virtual waterways. The swirling currents are simulated in real time. In these design rooms, every curve, every blade angle, and every diameter is scrutinized. Fluid dynamics, material strength, and energy efficiency all converge in this stage, forming the blueprint for a machine that must perform flawlessly for decades under enormous pressure. Once the design is finalized, attention turns to raw materials. High-grade steel, alloyed for strength and corrosion resistance, is selected carefully. These metals must endure the relentless force of water and resist wear and erosion over decades of service. Stainless steel, carbon steel, and specialized alloys arrive at the factory in massive ingots and billets. Workers inspect the surfaces, checking for cracks, impurities, or flaws that could compromise performance. Overhead cranes lift these heavy blocks, moving them with precision to the next stage, casting. Casting is where raw metal begins to take shape. In vast foundries, molds are prepared to form turbine blades, hubs, and casings. Molten steel, glowing bright orange, is poured into these molds with meticulous care. Sparks fly and steam rises as workers in protective gear manage the flow. The metal fills every crevice, forming the intricate curves of blades and runners. After cooling, the molds are removed to reveal rough, unfinished components, their forms emerging from the solidified metal like sculptures of industrial art. Each piece is inspected for uniformity, ensuring that no imperfection will compromise efficiency. Heat treatment follows, strengthening the components and relieving internal stresses. In enormous furnaces, turbine blades and runners are heated to extreme temperatures, then carefully cooled in controlled cycles. Quenching, tempering, and annealing processes enhance the material's hardness while preserving flexibility. Steam rises as cooled components are lifted from the baths, each piece now capable of withstanding the immense forces it will encounter once water begins to flow through it. Next comes machining and precision shaping. CNC milling machines, lathes, and grinding tools remove excess material, forming perfectly smooth surfaces and exact blade profiles. Each turbine runner is sculpted to micron-level accuracy. Coolant sprays glint under industrial lights as robotic arms adjust angles and operators measure every dimension carefully. This stage ensures that the blades, the hub, and the casing will fit together seamlessly, allowing water to flow efficiently without turbulence. Finishing brings the final polish. Blades are manually and mechanically smoothed to minimize friction and maximize flow efficiency. Inspection under bright lights reveals every contour, ensuring perfection. Finished components are lined up, gleaming, ready to be assembled into the turbine that will harness the river's power. Assembly begins with the turbine runner. Blades are carefully mounted onto the central hub, secured with precise bolts and aligned using laser tools. Guide vanes and wicket gates are installed to regulate water flow, their movements tested for perfect accuracy. Spiral volutes and casings, fabricated from welded steel and machined internally for smooth water passage, are fitted around the runner. Bearings and shafts are installed to transfer the turbine's rotational energy to the generator. Every connection is inspected, every alignment verified. The turbine now takes shape, a combination of molten metal, precision engineering, and human expertise. Balancing and alignment tests follow, ensuring the runner spins smoothly without vibration. Dynamic sensors measure rotational stability, and engineers monitor readings from control panels. Adjustments are made, fine-tuning the turbine for optimal performance. Coatings are applied to protect against corrosion and erosion, including epoxy and specialized paints, safeguarding the turbine from water wear and extending its lifespan. Factory tests simulate operational conditions. Dry runs rotate the runner without water, while small-scale wet tests allow water to flow over the blades, verifying performance and efficiency. Every measurement is recorded, every parameter confirmed, because a single flaw could compromise decades of service. Transporting the massive turbine components to the hydroelectric site is a feat in itself. Cranes lift the sections onto heavy-duty trailers, and convoys navigate roads carefully, protecting the enormous pieces from damage. Aerial shots show the careful choreography as turbines move from factory to powerhouse, a testament to human ingenuity and engineering coordination. At the hydroelectric plant, installation begins. Cranes lower turbine sections into the powerhouse pit, aligning them with the generator and penstock. Guide vanes are adjusted, bearings lubricated, and the shaft is connected to the generator. Every bolt, every alignment, every mechanical connection is checked multiple times. The turbine now takes shape, a combination of molten metal, precision engineering, and human expertise. Finally, the moment of truth arrives. Water is released into the penstock, flowing over the blades and spinning the turbine runner. The mechanical energy is transferred to the generator, producing electricity. Lights flicker on, machines hum, and the river's energy is transformed into power, illuminating homes, industries, and cities. The turbine, born from molten metal, precision engineering, and careful human effort, now performs its essential role, quietly and efficiently converting nature's force into usable energy. This journey from raw material to operational hydroelectric turbine is a story of precision, expertise, and industrial achievement. Every step, from engineering simulations to casting, machining, assembly, testing, transport, and commissioning, reflects a meticulous balance of science and craftsmanship. Hydraulic turbines are more than machines. They are the lifeblood of clean energy, a perfect synthesis of human ingenuity and the unstoppable power of water. The process is not only technical, but also cinematic in its scale and drama. From the glowing molten metal in foundries to the precise laser-aligned assemblies, every stage has its own rhythm and beauty. Heavy cranes swing massive components, industrial robots move with exact precision, and engineers, ever vigilant, ensure perfection. Each step tells a story of collaboration between man, machine, and nature. A story that transforms a simple river flow into electricity that powers the modern world.
It's holding steady.
In understanding how hydraulic turbines are made, we also understand the broader story of renewable energy, industrial progress, and human innovation. These machines are not just metal and machinery. They represent decades of engineering knowledge, careful planning, and countless hours of labor. They embody our ability to harness natural forces with precision and efficiency. Every kilowatt produced is the result of a journey that begins in a design office and ends with a turbine spinning in a river's current. The process of turbine manufacturing is a reminder of the remarkable feats humans can achieve when imagination, science, and skill converge. From raw steel to a fully operational turbine, each step is measured, tested, and perfected. It is a testament to the meticulous care and expertise of engineers, foundry workers, machinists, and installers, all working in concert to bring energy to life. When a hydraulic turbine begins to spin, it does so as the culmination of an extraordinary journey, a journey that transforms earth and metal, calculations and simulations, human effort and natural energy into electricity.